Ding!
Alright, well, let's get started. Today's problem will be a particle moving along a curve in the xy plane has position xt, yt, I'm pretty sure the bell rang at 7:40, not 7:42, but whatever.
It's not my fault Dunkin' Donuts had a long line.
Particle moving along, and interruption number 1, doo-dah, doo-dah. Now the girls.
Interruption number 1, doo-dah, doo-dah.
And the boys. Interruption number 1.
Doo-dah, doo-dah day.
A particle moving along a curve in the xy plane has a position x of t, comma y of t. For t is greater than 0. At time where dx dt equals 6 over t minus 3 to the 1/3, and dy dt equals t e to the negative t. At time t equals 3, the particle is at the point 5, comma 4. Find the speed of the particle at time t equals 3. dx dt at time t equals 3 is, Dylan? What are you, a freaking slug? Yes, Dylan, it equals 3e to the negative 3, which is approximate, never mind. It equals 6 over 3 minus 3 to the 1/3. Which equals negative 1. dy dt at time t equals 3 is I don't even know why I even do this anymore. Yes, 3e to the negative 3, which is approximately 0.149. Have to plug into the speed formula. And speed equals... Achoo! Please stop sneezing. I'm so distracted right now. Yes. Radical dx dt squared plus dy dt squared, which equals negative 1 squared plus 0.19 squared, 0.149 squared. Which in turn equals 1.011 is the speed. That answers question number A. Now, part B. Write an equation for the line tangent to the path of the particle at time t equals 3. I don't even know what that means, but whatever. Alright, part B. dy dx equals dy dt over dx dt, which equals t e to the negative t over 6 over t minus 3 to the 1/3. dy dx at time t equals 3 equals 3e to the 3 over.
Cala, I think it's -3.
That's what I put. Everyone mistakes, so yes they do. Your mother and your brother and your ugly sister too. So as I was saying, over 6 over 3 minus 3 to the 1/3, which equals -3 over e to the 3, which approximately equals -0.149. So, and now for part C. Is there a time t at which the particle is farthest to the right? If yes, explain why and give the value of t and the x-coordinate of the position of the particle at that time. If no, explain why not. Okay. Eastview Mall. dx dt equals 0 when 6 over t minus 3 to the 1/3 equals 0. Alright, I want somebody to call out the next step. Evan? Okay then. Yes, you cube both sides by 3. Don't know why that was so difficult. 6 over t minus 3 equals 0 when add 3 to both sides. 6 over t equals 3 when multiply both sides by t. 6 equals 3t. Divide both sides by 3 when t equals 2. Now, we do something called the first derivative test. X of t, dx, dt, t. If we plug back in to this equation a number before 2, such as 1, we know that it will be 6 minus 3, which is 3. 3 to the cube root is still positive, so dx dt will be positive. If we plug in a number after 2, such as 6, 6 over 6 is 1, minus 3 is -2. The cube root of -2 is negative. Therefore, dx of t is increasing, then decreasing, which answers our question. Is there a time t at which the particle is farthest to the right? Because dx dt is maximum here, it has to be farthest to the right. And this, it says, if yes, explain why and give you the value of t. We've given the value of t, and here's our explanation. So I had to zoom in for that for a little bit. And then we're going to have to be there for a while because the people are going to copy the answer. This thing's so itchy, I'm going to rip off my mustache soon. But now, oh, I can write D on this one.
Everything you're saying is probably going to be in the video.
What? I don't care.
Okay. How much longer?
I can stay there for a while.
Hate this tape.
Jenny, don't hate on my tape. That tape means business. Did we do D? Where is D?
I think
Oh, it's on the back. Oh, that makes sense.
Jenny, you're blocking it.
I'm sorry.
You want to take this off? Let's use this too.
Yeah.
Okay, if they're not done good by now, then they need to.
Do you want my
do it
dog to do the
faster.
video?
Could be.
Who do you want to play?
Um,
Who else is in that class?
Sebastian.
Yeah, but what does Sebastian do that's funny in that class?
Can I stop this now?
No, you're going to
Oh
stay
my
there. Audrey.
god. Oh my god.
I can't even tape this.
Who else is funny in that class? Who won't mind that they're in our video? Sebastian won't. Okay, let's make Sebastian Snoopy.
Okay, it's been like a solid minute.
That's good.
Describe the behavior of the path of the particle as t increases without bound. So we start this out with the limit of t, limit as t approaches infinity of dx dt. dx dt equals, Sebastian. Okay, don't answer. That's fine too. So, the limit as t approaches infinity of 6 over t minus 3 to the 1/3. As t approaches infinity, this is going to equal 0. 0 minus 3 to the 1/3 just equals minus 3 to the 1/3. This is the limit of dx dt as t approaches infinity. The limit of dy dt as t approaches infinity equals the limit of t e the negative t as t approaches infinity. Here we have to use L'Hopital's rule, which will bring us to what's the derivative of the top? T is 1. The derivative of the bottom, e to the t, is just e to the t, which equals 0 when t equals infinity. So therefore, as t increases without bound, the graph approaches the x-axis in the line y equals negative 3 to the 1/3. I'll repeat that. So therefore, as t increases, the graph approaches the x-axis in the line y equals negative 3 to the 1/3.
And playing Mr. Cala, Dylan. And playing Dylan, Jenny. And playing Evan, Greenface. And Sebastian, Snoopy.